All right, this video is for section 3.1, focused on quadratic functions and applications. So we've got 7 topics that we'll be talking about today. So the first topic is graphing a parabola in vertex form. And so this should be kind of familiar. I think we've done vertex form of a absolute value equation, and we may have even graphed parabolas earlier in the semester. So when we're graphing a parabola in vertex form, we want to start with the vertex. And so remember that if it's in this form, then the vertex is at hk. So for the parabola here, y equals x plus 3 squared minus 4, our vertex is going to be at -3, -4. So we're looking for the 0 here. That's why it's a -3. And then the k value does not change signs. The sign matches what's in the equation. So our vertex is at -3, -4. Especially in ALEKS, if the grid is counting by 2s like this one on the screen, make sure that you're very careful about placing your points. And then parabolas follow a 1-3-5 pattern. So you can use that 1-3-5 pattern to graph this. As you're doing it in ALEKS, it will ask you to graph 4 additional points. Usually I graph 2 on each side of the vertex. So up 1 over 1, up 3 over 1, and then the other side as well. And then you can click on graph and it will draw that parabola shape for you. Oh, I kind of missed. Close enough. If you don't like using the pattern, you can always just sub in. So once you know where the vertex is, just choose x values on each side. So maybe you choose -4 to start, and you calculate, you calculate -4 plus 3 squared minus 4, and that gives you the point -4. That's so -1 squared, so that's -3. And so that gives you the other point. So if you don't like using 1-3-5 pattern, just pick different x values and substitute them in until you have gotten 5 points for your graph. Okay, so now we're going to kind of do that backwards. If I have a graph shown to you, can you write the equation of that function? So vertex form is fine for this. So it's going to be in this form like this. Do be extra careful to not forget the vertical stretch. And you can do that. You can find the vertical stretch by checking the pattern. And also when you type these into ALEKS, don't forget the power squaring. Without the power, it is going to mark it wrong. And that's a common error I see. So first identify the vertex of the function. So this one has the vertex at +2, -4. So in the function, that shows up as a x -2 squared minus 4. And then we want to get our stretch. So I'm going to count off the pattern here. It's going up 3 over 1 and then up 9 over 1. So the base pattern for parabola is 1-3-5, but this one is going 3, 9, and then I can't count anymore because it's off the grid. So that's a stretch of 3. So I want to put that vertical stretch of 3 in front of the x -2 squared. For this other function over here, we've got the vertex at -1, -2. So it's going to be an x plus 1 squared minus 2. And then for the vertical stretch, it looks like it's going down 1 over 1, down 3 over 1, down 5 over 1. So our stretch is -1 or just a negative like that. All right, so that was our second topic. The rest of our equations today are primarily going to be in standard form. So standard form is this form where the function is equal to ax squared plus bx plus c. So it's not in vertex form anymore. For the Standard form, A does still tell you if the parabola is opening upward or downward. So for a positive leading coefficient, that parabola is going to open upward, like this top graph. For negative leading coefficient, it's going to open downward, like this bottom graph. A parabola that opens upward has a minimum value. A parabola that opens downward has a maximum value. We're going to be using the axis of symmetry extensively today. So the axis of symmetry is this sort of imaginary line that cuts the parabola in half, and both sides of the parabola are identical or a reflection of each other. And the way that you can calculate the axis of symmetry is that it's equal to negative b over 2a. So using the coefficients of the equation. So our first topic is just going to ask us several questions about the graph of a parabola. So it'll first ask if it opens upward or downward, so we can look at this parabola and see that it's opening upward. And then it will ask us for the equation of the axis of symmetry. Well, in this case, we don't need to calculate it. We just need to look at the graph and see it. And so the axis of symmetry is that x is equal to negative 2. The next one asks us for the x and y intercepts. It does just want us to list the values, not the points. So I can see that I have an x-intercept at negative 3 and another one at negative 1. So I just separate them with a comma, but you don't have to write them like points like this. You can just list the values of the x-intercepts. And then for the y-intercept, it's going to be 3. With y-intercepts, especially if it's a really steep parabola, make sure that you're very carefully finding that value. They can be sometimes hard to tell. Sometimes I'll check the pattern to make sure I've counted to the right y value. Okay, and then the last one asks for the vertex. So for this parabola, the vertex is at negative 2, negative 1. And it may shuffle the order of those questions when you're doing this topic, so don't just expect them to be in that same order every time. You'll just have to read and answer it, whichever question it's asking. Okay, so now we're going to use standard form to draw the graph. So the parabola that we're going to graph is 2x squared minus 4x minus 3. So the coefficients, remember, a is the leading coefficient with the x squared. B is the coefficient of the x, and c is the constant. So for the axis of symmetry, we're going to use the equation x equals negative b over 2a. So for this parabola, it's going to be negative 4 over 2 times 2. So there is always a 2 in the equation, and then our a value also happens to be a 2. So our axis of symmetry, negative 4 divided by 2 times 2 is 1. So our axis of symmetry is 1. Now, you don't necessarily need to graph that axis of symmetry or anything. The axis of symmetry is just giving us or helping us find the location of the vertex. So we know that our vertex happens somewhere along that axis of symmetry. We just need to figure out how high it is. So to figure out the y value, you just substitute it into the equation. 2 times 1 squared minus 4 times 1 minus 3. That's 2 minus 4 minus 3. So that is negative 5. So the axis of symmetry gives you the x coordinate, and then plugging that x value in gives you the y coordinate. So this has a vertex at 1, negative 5. And then you can either substitute more x values into the equation, or you can use the 1, 3, 5 pattern to help you plot additional points. You'll need to plot 4 more points. Just make sure you watch out for the stretch factor. This one's stretched by a factor of 2. That a value is 2. So we're going to count a 2, 6, 10 pattern. So up 2 over 1, up 6 over 1, and then just reflect those back for the other side of the parabola, and then you can hit the button to plot it. Okay. One of the topics is just going to have you report the minimum or maximum value of the quadratic function. So it'll give that function to you in standard form. So we have the function negative 2x squared minus 20x minus 50. It'll ask you whether it's a min or a max, what the function's max or min value is, and then where does that max or min value occur. Alex does sometimes scramble the order of these questions, so make sure you're reading what it's asking. It doesn't always go in this order. So the first thing you should do, regardless of the order of the questions, is do a rough sketch. And I know it seems silly, but people often accidentally pick the wrong one between min and max, because if you're just thinking, oh, it opens upward, sometimes you want to translate that into a max in your head. But if it opens upward, that's actually a min. So this parabola opens downward. So a rough sketch helps me just remember that that is a maximum right there. So if it opens downward, you'll have your little U shape like this to help you remember that that's a min. So we've got a parabola opening downward, so we've got a maximum. Regardless of what order Alex asks the question, you want to find the x value next. So even though it's at the bottom, I'm going to go to this one now. I'm going to use the axis of symmetry here. Negative 20 over 2 times negative 2. And that is positive 20 divided by negative 4. So that's negative 5. So that's the x value where the maximum occurs. And to find out how high it is, which is the maximum value itself, we're going to sub in that negative 5 into the function. So it's going to be negative 2 times negative 5 squared minus 20 times negative 5 minus 50. And if you calculate that, you get 0 actually. So the function's maximum value is 0. Our last two topics involve finding the max or min of a quadratic function, but they're like word problems, which I know sometimes people don't love. But really, these word problems just involve finding the vertex of the quadratic function, which is what we've been doing. The first word problem topic has the equation for you, similar to this. So it tells us the population is given by this quadratic equation with some very big coefficients, where that's the population and time is hours since the culture was started. So instead of having an x, we have a t as our independent variable. So the first question is saying determine the time at which the population is a maximum. So this is having a negative coefficient. So it is a parabola that opens downwards. So we are looking for a maximum on this problem. So we'll use the axis of symmetry. Negative b, whoops, I missed my 2. Negative 82,000, the negative b over 2 times a. And if I calculate that, I get 23.865 hours. And Alex will tell you how to round. I think on most of these it says do not round. So they'll probably have some truncating decimals that you can report. So it will have a maximum population after 23.865 hours. So that's the time at which the population is max. And part B says determine the maximum population. So this time we're doing a population calculation at that x value. So negative 1718 times 23.865 squared plus 82,000 times 23.865 plus 10,000. And I don't think most of them have numbers this big, but this one does have big numbers. Let's see, let me just crunch that really quick. Okay, so we get that the population is 988,463.3295 bacteria. So when you're doing this particular topic, it's not going to have you answer two parts like we just did. It's just going to ask you one or the other. But it's not going to tell you, hey, this one's an X and this one's a Y. It's just going to have the question written in words. I should have used a T on this one. So you have to read the question. If it says determine the max population, then you're looking for a P, so you're going to have to do two steps. You're going to have to do the AOS, axis of symmetry, and then plug it in to get the answer. If it just says something like determine the time at which it's a max, or the X value in some way referring to the X value of your problem, then you know that all you have to do is get that axis of symmetry and you're done. So you'll have to get used to kind of reading and deciding, is this asking me for the Y value? Do I need to plug it in based on this context, or is the axis of symmetry the end and I just need to type that in? Also, when you're doing this topic, watch out for questions that aren't in standard form. So like this one gives you the height as 44t minus 16t squared. So the A is not 44 and the B 16 because that is not in standard form. So to avoid an error there, if you hopefully can look and notice when they're not in standard form, and either just think of this as A and this as B, or rewrite it to help you realize which one's A and which one's B. But it does need to be in standard form for, you do need to use the t squared coefficient as A and the t coefficient as B. Okay, the last topic is word problems as well, but you also have to work on setting up the equation. The equation is not given to you, so we have to use the context to create the equation. So we have Frank has 180 meters of fencing, and he is going to form 3 sides of a garden. But the 4th side does not need a fence because it's going to be along the house. So the house itself serves as that 4th side of the fence. So one of the sides of the fence we are going to call X, and our job first is to create a function that gives the area of the garden. Well, if this side of the rectangle is X, then this side is also X. So we've got 2 X's. Our total fence length is 180 meters. So when we think about the fence here and the fence here, we've used 2x, so that means this other side we could call, or it will have a length of 180 minus 2x. So this is an expression for, how much of the fencing is left. So we have our 3 sides labeled, and we are creating an area function. Well, area of a rectangle is length times width. So our area is x times 180 minus 2x. And in order we are going to find the maximum of this garden, maximum area of this garden. So we want to put our function into standard form. So the area, if I distribute this, I have 2 terms. Leading term is going to be negative 2x squared, and then we'll have a positive 180x. So I kind of changed the order of those terms to put it into standard form. Okay, so we have our equation for area. We want to find what side length gives the maximum area of the garden, and then figure out what that maximum size is. So for this side length, we're finding that x value using the axis of symmetry. So that would be negative 180 over 2 times negative 2. Negative 180 divided by negative 4 is 45 meters. When it asks for the maximum area that the garden can have, that's asking you to actually calculate, oh, that's a typo, area. Actually calculate the area if the side is 45. And you definitely can do that by substituting your x value into the equation. And that will give you the answer. Another, I think, somewhat quicker way is to just go back to your diagram and think about, okay, this side length is 45. The other side length is 180 minus 2 times 45. So this other side is 90. So my area is 45 times 90. And those two things will give you the same answer. It's just two different ways, just however it makes the most sense to you. And then those should both give you 4,050 square meters of area. There is a variation on this word problem that you do have to enclose all four sides. So, watch out for that. Don't just mimic what we've done here. If it is all four sides, you will have to sort of set up the equation a little bit differently. Here's kind of a variation where all of the sides are enclosed. We've got a wire. That's a little bit of a convoluted scenario. We've got a wire that's 32 centimeters long, and the wire is getting cut into two pieces. And then each of the pieces is bent to form a shape of a square. So we took this long strip of wire and we bent it into two squares. So we have one square that we've marked an x as the side length. We want to find a function for the area enclosed by the two squares, and then we want to find the side length that minimizes the total area. Well, these are squares, remember, so if this side is x, then all of the sides of this shape are x. So we have 32 centimeters total, and so far we've used 4x. So that leaves 32 minus 4x for the other square. So if we think about the sides or the side length of this square, we have 32 minus 4x, and we need to make a square so we can divide that by 4 for each side. So 32 minus 4x divided by 4 is 8 minus x. And that's what, that's what the four sides of this one are, 8 minus x. Okay, so we're ready to write our area equation. So we have to add the two areas together. So for the first square, the area is a length times width, and for a square, those are both x. So x times x is x squared. So that's the first square. And the area of the second square, well, it has a side length of 8 minus x, and that's going to be times by another 8 minus x, length times width. So in my diagram, that's the second square, or the area of the second square. So we want to combine this into standard form so that we can calculate the axis of symmetry to find that side length that minimizes the area. So we do need to multiply this out and then add this other x squared to it. So this gives me 64, 8 times 8. 8 times negative x is negative 8x. Another negative 8x, and then a positive x squared. Now that was just the second square, so we still have the x squared from the first square as well. So if we combine up our terms, we end up with a total area of 2x squared minus 16x plus 64. So that's just combining the two x terms together and combining those two negative 8x's together. So this is our area equation. All right, so this parabola does open upward. It has a positive coefficient of 2, so the vertex is the minimum. So we are going to find the minimum value, and first we got to find that side length x using the axis of symmetry, negative b over 2a. So for this, we have negative b is negative 16 over 2 times 2. Negative 16 divided by 4 is, negative 16 divided by 4 is 4. So the side length x that minimizes this total area is that each of these sides needs to be 4. And now it asks us, what is the total minimum area enclosed? So just like before, you've got a couple choices here. You can either calculate it using your equation, and that will work really well if you like that method. My 6s look really good today. And then if that works for you, go ahead and do that. You end up with 32 as your answer. If it's easier for you, though, you can go to the diagram. We just said that x is 4. That means the area of this square is 16. And then the other area, the side length, is 8 minus x. That's 8 minus 4, and that is also 4. So then we have this other one that is also side 16. So 16 plus 16 equals 32. My 6s, oh my gosh, there they go. So either way, you'll get that same answer. So you can either go to the equation to get that final answer, or you can use the diagram to kind of help you get your final answer. Okay, so 32 centimeters squared. So the minimum area enclosed happens when the two squares are exactly the same length, which means that you started out by cutting that wire right in half. All right, so that was the last of the topics for section 3.1. This one is due the upcoming Sunday. And so if you have questions on these topics as you're working on them on Alex, let me know. Thank you.